I'm Roger Howe. I guess some of you know me from last summer, and I've been running seminars for the past 2 summers and several before that. So when Jim asked me if I'd like to do a seminar this summer, I thought about topics, and something that came to me was the number line. And when I thought of doing a seminar about the number line, I sort of wondered, why hadn't I done this before? Because the number line is such a basic object in mathematics. It is the connection between arithmetic and geometry. And we use it in all kinds of contexts. When we put 2 number lines perpendicular to each other to coordinatize the plane, and we add another one to make free space, and then we can adapt that, sort of curve that around to parameterize all kinds of other objects like the sphere with longitude and latitude. So it's the basis really for dealing with geometry numerically. But also, so there's 2 conundrums that I've worried about in regard to the number line in school mathematics, and one is, well, the main one is, so why isn't it sort of a more seminal object? Why isn't it better used? And I don't know the answer, but I've made some guesses. And I think one problem with the number line is sort of the prehistory of the number line is not adequately developed. So, first of all, students are never taught the basic principle for putting numbers on the number line. There are some very touching videos available which shows a class trying to figure out where to put half on the number line. And they make a lot of different guesses and have a long debate, and with some prodding from the teacher probably eventually come to the right place. But it's really a difficult process for them. And so I've realized that many students never grasp the principle by which numbers are put on the number line, which is, I will state it for you. I wish I had it to put up on the screen, but it's a little bit complicated, but let me say it. So it's the measurement principle. So a number on the number line tells you how far that point is from the origin as a multiple of the unit length. So if I say that explicitly to you, I think you'll all recognize that's how you think about it. But it's a complicated idea, right? It involves, first of all, measurement and distance, and then also ratio, right? A ratio to. So this is not something that students are going to intuit for themselves. I think it has to be taught explicitly. And so there's a prehistory there, and you would start out by getting them used to the fact that arithmetic can be done in the context of measurement. So you would take a bar of length 2 and a bar of length 3, and you would put them together and have them say, oh, that's a bar of length 5. And you do a lot of exercises like that. And you could do those also with tens rods and one cubes, and have them see how that's a way of adding 2-digit numbers together and so forth. So there would be a lot of prehistory to putting numbers on the number line. And then after you do that, you would be able then to place fractions on the number line. And especially with the Common Core new approach to fractions, so like we now understand a half as something of which it makes 2 to make the unit. Half is no longer 1 out of 2, it's a quantity relationship. And other fractions are also quantity relationships. And so you can see that you would put halfway between 0 and 1, because you have to go that distance twice to get to 1. Or you would put 1/3 of the way, because you would have to go that distance 3 times to get to 1. So you would develop the idea of putting fractions on the number line using the measurement principle. And then you could see, if you do that when you talk about adding in terms of putting lengths together, it's exactly the same process, whether you're doing it with fractions or with whole numbers. And this would help to unify the idea of number. So this is sort of the prehistory of the number line. And then there's a lot of further possibilities that are almost completely ignored. And I'd like to explore some of those in the seminar. I don't know if we'll revolutionize the curriculum, but I'd like to show you how the number line relates to multiplication. So could you show that slide? So usually, so we can think of the number, the next actually I should say in the number line in addition is, so you could think of, okay, I have 2 and I want to add it to something, so I can take that something and then I can take my length of like 2 and move it over until its left end starts at the right end of the other something, and then I see how far it sticks out. So I could think that basically what I've then done is I've slid the number line over. So the adding 2 to something becomes a translation of the number line, kind of a transformation of the number line. And here is there's a way to think of multiplication also in those terms, which is much less commonly discussed. And so the idea is that multiplication, you can think of it as stretching the number line. So here, down here, is the regular number line, and here are the units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I stretch them, each one of them by 2 units, you see, then I will multiply any one of those numbers. So if I take 2 and stretch the unit interval and the next interval by 2, then the end of that is on 4. So I've multiplied 2 by 2. Or if I wanted to say multiply 6 by 4, so 6 is the blue one, so I go up to the 4 and go out to the end there, and I see that, by golly, that ends on 24. So you can think about multiplication in terms of the stretching operation, and this is a much harder thing to visualize, and that's probably part of why it isn't seen very much in the curriculum. But I think it's a very beautiful way to think about it. And also, if you think about this, it can help get rid of some of the mysteries of multiplication by negative numbers. Because what would multiplication by -1 would be? It would be flipping the number line over the origin. Well, if you flip the number line twice, multiplied by 2 negatives, right, you get back to where you started. So a negative times a negative is a positive. So I think there's a lot of possibilities here, and it goes on. And so a big staple of middle school and high school algebra are linear functions, ax plus b. They can also be thought of as transformations of the number line, and the geometry of those transformations gives you quite a bit of insight into the algebra that you're doing, and lets you actually go on to further topics that are considered even more advanced than high school. So the number line has a tremendous reach. It stretches a long way, if you forgive me. So I think it would be make a very interesting seminar to explore all these possibilities, and I'd like to do it.